Okay, hi everyone. I hope this video finds you well. Okay, so today we are going to talk about structures. And before we talk about structures, we are going to have a review of variables. Then we're going to start talking about structures, creating and using structures, operators for structures, how we pass them and we return them to and from a function. Vectors of structures and pointers to structures is the last thing we are going to talk about today. And before I start this lecture, I want you to fire up the Visual Studio 2019 and start a project and call it Sandbox 9. Okay, so besides the normal variables, what other kinds of variables do we know of? So we know of arrays, vectors, and last but not least, pointers. So basically, what is special about them? What makes them special? Okay, for array, you can store many elements of the same type. For vectors, you can store many elements of the same type, but it's using the dynamic memory. So it's storing the elements in the heap. With pointers, you can point to dynamic memory. If you want to use dynamic memory, if you want to use the heap, then you need something to store the address the operating system is giving you back once the memory is allocated, which is pointers. Okay. So basically what is important about them is that you can make decision about memory at runtime, and we are talking about pointers and vectors. With pointers and vectors, whenever you use the heap, you can grow or shrink your memory locations, like the vectors. I can have vectors of 5 elements, then I decided to grow it to 10. I can do that at runtime whenever a space is needed. With pointers, you can ask for memory at runtime that uses the heap and you store it in pointers. Okay, so what about structures? Why do we say those things? Because today I'm going to teach you how to define a new data type. So it's not like the int you know of, it's not double, it's not a float, it's your own data type, something you create. So if your name is Jake, if your name is John, Sam, Elise, whatever your name is, you would be able to create a data type of your name, and you decide what that data type would represent and what it holds. So the second point is that you can create that data type, and that data type can hold multiple pieces of data. So you can have different data types inside. So talking about my students in my classes, I want to create a data type that represents all of them. So I'm going to name it student. So the student data type is going to have a name. So my student is having a name, ID, email, year, whether it's a freshman, sophomore, junior, senior, and all these things. Maybe grades, courses. It's gonna be like depending on what you choose to have in your data type. Okay, talking about keeping that student in mind. So the way I define my structure, my new data type, is by using the keyword struct. Struct is from structure, so struct. Then the name of your data type, then you open curly braces and closing them. And the most important thing is you add the semicolon. It's not like functions and loop bodies where you open and close brackets only. No, you would need this semicolon, and we will know why in a few minutes. And you get to have a body of that structure. The body is going to be the member variables. It's called the member variables. So the name is going to be of type, for example, string. The ID is of type int. If a grade, like for in my class, or maybe we want to have more than one grade, like vector of grades, maybe array of grades, depending on what you choose. And I'm going to tell you the difference in both. So how is that structure represented in the stack? The way it's represented, when you create a variable of the new data type, like student, student1, exactly like int x, right? Exactly like creating integer variable. So student, student1, then student1 is going to locate three variable locations. One for the string, one for the int, and the other one is for the other int. So the name, ID, and grade. Student2 is going to do the same thing. Three other locations, name, ID, and grade. So how do we access this? Because I created student1. How do I access name or ID or grade? Using the dot operator. So the dot operator allows you to access the member variable. So if I'm going to assign value to the name, I would do, in student1, then I would do student1 dot name equal the name, Will Smith, for example. If I'm going to assign a student name or a name to student2, then I would do student2.name Jet Li, and so on with the ID and the grade. So basically, these things, when I create these two variables, I created two variables of type student, but those are uninitialized. So I initialized just the name in student1 and just the name in student2. However, those are not actually empty. There is some garbage value in here, garbage value in here, garbage value, garbage value. So there is something, it's garbage value. So revisiting my student, just one grade. Am I talking about GPA or the grades of the courses? No, I'm talking about the grades of the courses. So one grade is not enough because usually most students wouldn't have just one course. So we can create a vector of grades. A vector of grades. Now, I want to show you something before we move on. You can create a vector or you can create an array. You can create an array of grades. Like if you have 10 courses, 10, 3, you can initialize them all to 0. You can set the first one, for example, to 10 or for 100, the second one to 97, and so on. Now, this is just an example I wanted to show you. Now, going back to this, why do we choose to use vector, not array, usually? Actually, if you tried using array in old compilers, it's not going to work. Why? Because it's going to exhaust the stack, and we usually use dynamic memory because we don't want to exhaust the stack. This is why we have vectors. So vectors, the way vectors work is exactly, they're creating just the location of that variable in the stack, like adding the grades. And this is going to point to something in the heap. Something like this. Something like this. So, the grades, it's just storing the memory of the first location in the heap. Or you can think of it that way because vectors are kind of objects. which is something you don't know of by now. It's going to be in C++2 in next quarter. So basically, we want to use vectors to save some space in the stack, and we can use the free store, the heap. Okay, so I want you to think of your canvas, the canvas for your class. So there is some information that is needed for each student account, right? So think about if we wanted to create a structure to store all the student information needed to contact a student or maintain their grades, storing and maybe calculating. So the way you would do it is you open your grades section on Canvas, then start writing some member variables that you would think of on a paper. So pause the video, do that, and come back to see the answer. Okay, assuming you tried that and you want to check if you got things right. So this struct, you have a struct, and whatever you want to call it. So if you call it Canvas student or just a student, that is going to be okay. And you're gonna have a name for the student, an ID, email, vector of quizzes, because usually you would have more than one quiz throughout the quarter. And vector of programs and homeworks, like mini homeworks, exams usually would have more than one. And for the percentages on your canvas, you would have the percentage of that. So for example, if you have 10 quizzes, each quiz worth 10 points, and you did well in like 8 of them and a little bit bad or not very well in the other 2, and your final result was 87 out of 100 for the all 10 quizzes, then the percentage is going to be 87% for this one. Same thing for the programs, the homeworks, and the exams. Also, you might have timestamp, which could be totally another structure, and you would have last activity, and that is going to stamp the time of day and the date and the exact hour, minute, and second. So the time, for example, for the total activity, this is the number of hours you spent on Canvas, or the number of minutes, and so on. And never forget that you are required to have this semicolon. So what operators we use for structures? There are 5 operators that you can use with structures. The first one is the dot operator. The dot operator, you can access member variable of a structure using the dot operator. So student.name equal assigning a student name or a name like Jason Statham. Then if you want, you can also use it to print. So student1.name. To the assignment operator, the equal sign, which is we use in C++ as the assignment operator. This is copying one structure totally to another. So copies all the members variable. And we tend to not do that because this is going to exhaust the memory. It's going to use a lot of memory. The reference operator, the one we use if we are passing by reference. And the dereference if we are using pointers to structures. And the address of if we want to get the address of a structure to store it in a pointer. So those are the 5 operators. Okay, so here's a silly example when we pass structures to functions and potentially returning them or returning a result. We are going to see how do we pass them and how do we return structures. So here's a function that returns an int because it's gonna be return average student grades, and student S1, student S2, we get the average of the grades of both students. So how could this function be made better? Yes, we can pass a student, but how can we make it better? What is better than just passing a structure? The better thing is passing by reference, not passing by value, because that was passing by value, and that is copying and pasting the student. So we spend much time in copying and pasting and memory. And this way, we get to use exactly the one we are passing, right? The one we are passing. So this is gonna save some time and it's gonna save some memory. So having them in as a reference variables. And we said that in previous lectures. So returning a structure, we can, if we have a function get student info and we define a student variable, then we store the name, ID and grade, and then we return a student to be stored in here. So pretty much we did the same thing. We created a new student, then we returned the student and we copied that student information into the new student structure. That takes a lot of time and takes a lot of space, and we don't want that. So it could be made better if the get student info is now passing by reference, and we reference this one, and we immediately fill in the information into the name, the ID, and the grade. So that is gonna be better than just having passing by value. If you're just using a student, you could have made it just const, but since we are actually modifying the name, the actual ID, and the actual grade in that student, it's gonna be just passing by reference, not constant reference. Okay, so structures also can be used within another structure. So if we created a structure, date is gonna have the month, the day, and the year, and we have a student, and we're gonna have the student birth date of type date, which is this structure. So this structure, and one thing that you have to be aware of in Canvas, in Visual Studio, whenever you use a structure, it's gonna be above the structure you're defining in. So if we are using date, if we are creating a variable of date, so date must be above where it's being used. Above the place where it's being used. So how do we use it? We create a student, and if we want to access the month, for example, then you first need to access birth date using the dot operator. Then after the birth date is going to have 3 member variables. One of them is month, again using the dot operator, and that's it. That easy. So here's some questions. If we have date, for the space of the slide, I don't have date above the student, but in Visual Studio you must have date above the student. So we have date and we have student. So the student is using a date variable. It's called birth date, and we use them as we define a student std. So if I do std, what is that type? And if I do std.id, what is that type? Birth date and month. So std is of type student. So that is student. ID is go to student, and what is ID? It's integer. So that is int. Birth date, go to birth date, and it's of type date. This is the type. And month is now of type, month is in birth date, so go to birth date of type date and find month. Month is of type int. Check it. So student, int, date, and int. Okay, so member vectors of arrays. So we said we prefer to have a vector. We prefer to have a vector in our structure, not an array, because we don't want to exhaust the stack. But you cannot have a preset or a pre-sized vector. You cannot set the size to the vector in your structure. You can have a generic vector or a dynamic vector, but not a vector where you set the size before compile time. So if you try to do this, this is going to give you a compilation error because the initialization with the parentheses is not allowed. Actually, they made it an exception for arrays, the one I just showed you in here. They made an exception with arrays, you can initialize an array. But for vectors, if we tried to import vector like this, let me just include vector and change this. Let me just comment that and change that to vector of int, and I'm gonna call it grades. And let me just do this. That is gonna be okay. But if you try to do this, for example 10 or 20, then you can see there is an error. If you try to run it, you can read that error, and that error is going to be that you cannot use the parentheses or something in that description. So it's going to be something in 19. Is it 19? 19 says subscript requires array or pointer type, and when you do that in 13, it says constant. Because now it thinks of your grades as a constant. It's not dynamic, and you use the constant inside, and it's not accepted. So this is going to work. Since now it's dynamic. Now the way you can access that grades, if you want to print the student grades, first you can have another vector of grades, vector of your new type, vector of students, vector of your new type. So I defined 50 students in my classes, and I filled the students information in here somehow, and then I have a for loop or embedded for loops that is going to go through every student, print the name, and then print their grades. So printing the student name, then printing their grades. How do I print their grades? Here is the student size, which is this one, and with this one I can do students of num student, which is this variable, dot grades, because I may have, for the first student, I have only 3 grades. For the second student, he or she has like 5 classes, so that would be 5 grades, and so on. So I would make it dynamic. So students, num student, dot grades, dot size, then printing that. Exactly like you used it in lecture 7 in vectors. Or you can use it in a for each. But always remember that for each is by default passing by value. This, if you changed anything, for now we are just printing, so it doesn't matter. We can print the same way. It doesn't matter for us, even though we are gonna be spending some extra locations and some extra time on passing by value using the for each. But it's okay. It's not that much. And here, if you weren't printing, if you're just storing information for students and so on, this one is gonna work perfectly without any problem. You just say this and equal to the new information. However, in here you have to have ampersand for the student, and with this one you have to also get to see the ampersand of the grade and the grades and all these things, right? So structures can be initialized with initializer list, the way you did with vectors, the way you did with arrays. So if I have student 1, this one is uninitialized. If I want to initialize the other student, I can do the name first, Ben Johns, and then ID, here is the ID, and for the vector, you can use initializer list for the vector, and that's it. And that's it. If you want to print them, you can print them like this if you want. So pointers to structures, and this is very important. So what if we wanted to have pointers that are pointing to structures? So we have our structure in here, and we are going to create a student variable, but that student variable is going to be located or stored in the heap. So you need a pointer. So we are going to use the new, which is asking the operating system to store that student variable in the heap. And new student, now we are talking about the heap, something in here. And that is going to be returning an address. The address is going to be stored in the stack. And we are going to store that in stdptr. This one. So now, what if, so this is gonna be like 3 things, the name, the ID, and the grade. What if I want to put a name in here, like Biff? So I would do asterisk, dereferencing the pointer to access the variable, right? Dereferencing the pointer, dot name, Biff Gladstone. But this is not gonna work. Why? Because the dot has a higher precedence than the asterisk. So basically, it's first going to try to use the dot on the pointer, which doesn't make any sense, right? Using the dot on the pointer. The dot is used on a student, not a student pointer, because the pointer is just storing an address, not an actual variable, right? Storing actual data, it's just storing an address. So an ugly fix would be forcing the compiler to treat the dereferencing first. How? By parentheses. We have done this, then, this. Then now it's dereferenced. You can use the dot, but this is an ugly fix. Do we have something nicer than this? Yes, we do. We have the arrow operator. The arrow operator is dereferencing, then accessing the member. So doing this first, and then doing this second. So I said I'm going to tell you why do we have this semicolon after every structure. The reason for that, because you can create a global variable of that data structure immediately, like this, without the need to go to the main to create a date yesterday, or a date today, or a date tomorrow. No, you can do yesterday, today, tomorrow. So now we have created 3 uninitialized date variables. So now you can access them today dot month equal 11, tomorrow dot month equal 11. So a class exercise right now, create a time structure that has hours and minutes. And create 2 variables, start time and end time. And those variables, the start time and end time, set them equal to the starting and ending time of this class. And if you're taking this class online, then set them equal to the starting time of your current study session and the anticipated ending time. So I want you to pause the video, start working on this one, and come back once you're done to see the answer. Okay, assuming you came back to see the answer, here is the answer. So I'm just creating a time, struct time in an end hour and end minute, setting the start time and the end time. Now I'm going to do that in different ways with you. So let's just go to this one. I'm gonna remove this one. I don't need it anymore. I'm gonna remove this one too. Let me just create a time structure. So struct time, and I'm going to have two things inside: int hour and int minute. So I'm going to one. I'm giving the way I showed you in the answer in the slides. I'm going to do this. Time starting time, ending time, and I'm going to set the time for those. Starting time dot hour equal 12, and starting time dot minute equals 30. Same thing I'm going to do with the ending point. So it's just okay, that works fine. Let me just paste this one in here and say this is ending, and same thing, copy that and paste it. It ends like at 2:45. Now I will print them. So cout starting time dot hour starting time dot minute, and have that in here. And line, I'm just gonna say that this is the starting time. Starting time is this. Same thing, I'm gonna copy that and say ending time and use that in time. Okay, let's run it, and that should be working fine without any problems. As you can see, everything is good. Now I want to show you something else. I want to take these two and remove this one and put them in here. And those are working fine without any problems. As you can see here, everything is working fine. Also, if you want to do something like this, like 12, 30, or 50, and this one equal to 30, and we comment this. Oh, sorry, this is comma. If you want to do something like that, you still can do it. As you can see, you can play with it the way you want. You can have them both in here if you want. Without doing this whole thing, you can just have them like this. But those are going to be of type time. And again, everything is going to be working fine without any problems. One last run. And that's working fine. Okay, so what I want to show you is that I would put the start time to 70, so 1270, which is a time that does not exist, 1270, and try to print it. And you can see that this one is still working. And it's going to print that the time is 1270, which is something that does not exist in our real world, right? So, going back to this, let's have a review, and I'm gonna tell you about the 70 thing. So, what do structures allow us to do? Create a new data type that can hold multiple pieces of information. Members data can be different data types. Two different structures or structure definitions may have the same member names. So I can have something like this. So I will start like time and another time. I'm just gonna call another time, and perfectly without any problems. So what are the two problems that normal variables and structures have in common? One, they contain garbage information with old compilers. So if you have date today and try to, without even setting the day, you can print it in old compilers. And in old or new compilers or any compiler in the world, no error checking. So the program has direct access. So if I said I have the minute 70, I cannot control it. It's just locate. You can think of them as just vessels. You can store things inside. So you cannot check what is the month. So the month is going to be 1 to 12, and that's it. If you entered 13, for example, there is going to be some kind of error checking. You have to do it on your own, not part of the structure. You have to do it an external code, like in main or something like that. So how do we solve this? We solve it by using classes, which is going to be next quarter. So that's it for today, and here is the lecture 9. I hope you enjoyed the video. Have a great day.